In this video, I'm going to be doing some additional practice problems on trig that's in this book that I've been following, and this will wrap up the section on what this book calls the advanced algebra and trig section. And then I believe the next unit would be on geometry. So I don't know if I'm going to be filming those anytime soon, but you can look out for that sometime in the future probably. All right, but let's wrap this up. Number one. By the way, as always, you should try these problems first before seeing how I think through them and solve them. In the right triangle shown above, if tangent theta is 3/4, what is sine theta? Well, tangent, this is a right triangle, so we're good. You should always check. Tangent theta is 3/4, so opposite over adjacent. This is a 3, 4, 5 right triangle. You should know that. Just quickly get the side. It's a special right triangle, 3, 4, 5 triangle. So sine theta is 3/5, opposite over adjacent. In the isosceles right triangle shown above, what is tangent of A? Well, since this is a right triangle and these two sides are congruent because it's isosceles, then this has to be 45 degrees here and 45 degrees there. Okay, so you can use your special right triangles to get this side over here, which is s√2. Okay, this is S, by the way. So tangent, by the way, we didn't even need that, but I was thinking of maybe we needed it, but we don't. Tangent of angle A is S over S, which is 1. Okay, so this is actually a waste of time to get this length, but didn't cost me too much time. So you should just, moral of the story is don't get what you don't need, even though it could have been helpful. Okay. So this should be, I believe, 3 and 4 refer to this guy. POQ is K pi radians. Okay, what is the value of K? Well, how can we get this now? Which triangle does this seem like it gives? The x is -half, the y is √3/2, right? So what angle does this guy have to be? This reference angle theta. This is theta over here. What's this reference angle theta? Looks like this has to correspond to 60 degrees, or theta is pi/3, right? So then, if theta is pi/3, what is this much over here? Has to be 2 pi/3. So k is 2/3 then. Okay, why is it 2 pi/3, by the way? Well, from here, swing all the way to here, that's pi radians, or 180 degrees. This is pi/3. So what's left? This has to be 2 pi/3, because 2 pi/3 plus another pi/3 equals pi. Okay? What is cosine of k plus 1 times pi? What is this strange problem? Is it that strange? What's the trick? Well, our k, which we found here, is 2/3. So k plus 1 is 2/3 plus 1, which is 5/3, right? So it's asking what is, by the way, I think this notation is not even right. Should have been like this. There's a terrible notation on this publisher, whoever wrote this, because it's cosine of k plus 1 times pi separately. This is totally different. So if you got confused by that, hopefully this clears things up, but that was a no-no on the editor. This will cause a bug in a program if they're trying to write a program. Okay, so where is 5 pi/3? Well, 3 pi/3 is here. So 4 pi/3, 5 pi/3, or you can think of it as, this is almost 6 pi/3, which is 2 pi, so it just shorts by pi/3 over here, okay? So what is the cosine there? Well, the reference angle is the same. Okay? So we can just use this triangle, and then we'll consider the sine afterward. Okay? So cosine is 1/2/1. So it's half. But now let's consider the sine. Actually, this is like the only choice probably, right? But let's just do it for the heck of it. Cosine's the x coordinates, in the unit circle. So is this x-coordinate positive or negative? It's positive, so it should be half. Yep, that's right. I was trying to find where it is. Okay. In triangle ABC above, AC perpendicular to BD, which defined does not represent the area of the triangle ABC. So this is a strangish problem, but how can we get the area? It's base times height, okay? So maybe let's get the height first. Height is equal to BD, okay? So how can we get BD? Let's peek at the choices. This sum is probably has to do with AD and DC, so let's skip over the first, or the second term technically, because the half's the first term. Let's look at the last term that's being multiplied. We want BD, okay? So what's cosine of ABD? Cosine, this angle over here, is BD over BA, or AB, BD over AB, and then we're multiplying by AB, so let me write it over here. BD over AB times AB, so we get BD, let's keep that. Sine of angle C is BD over BC times BC, so we get BD, that's fine. Sine of A is BD over AB, so that looks fine. BC cosine of C. Cosine of C is DC over BC. So this is getting DC, so we can eliminate D. So we eliminate just one choice from getting the height. Let me, for completeness, write it over here. Sine of A is BD over AB, right? Okay. So we eliminate choice D. Now we got to get, so now we're focusing on here. What is BC cosine of C? What's cosine of C? Cosine of C is DC over BC, right? So this guy, I'm just going to write, is equal to, actually, let me just write it. Cosine C, I said, was DC over BC. So this is the same. That's good. What's sine of CBD? CBD sine is BD over BC. Actually, did I do that right? I didn't think I did. CBD sine is DC over BC. Okay, so all these get DC, so that's fine. Now let's look at these. So this, we had to go through all the choices, at least that's how I'm thinking through it. AB times cosine A. What's cosine A? That is AD over AB. That's fine, that's fine. So then this one, so something, I must have missed something in the beginning. Let's check this one though. ABD sine is AD over AB. Okay, so I missed something. Let's see what's happening. Oh, this does not represent. So answer is D. Because all three are representing. So does not represent. Usually they capitalize, so it's clear. So answer is D. So I kind of eliminated it from the beginning. Okay? Isosceles triangle above, what is the value of sine of x? Okay, so this is probably that trick problem, like that, the one that came up in the other video. This is not a right triangle. Okay, so we can mark that as 20 though. We can draw a bisector. That's the term. I really don't remember vocab terms. So this length will be 12, this length will be 12. This bisects this segment AC, and it'll be a right angle there, okay? So now we can get sine of x, right? The side would be 400 minus 144. That's this height. Let's call it h. Okay. So what is that? That is 256, right? Isn't that 16? So sine of x would be opposite 16 over hypotenuse 20, which is 4/5, right? Answer is D. Okay. Triangle ABC. The measure of C is 90. So I'm already wanting to draw this. C is 90. AC is 24. BC is 10. What is the value of sine of A? So what's this length over here? What's 24 squared? That should be square root of 576. I did it in my calculator. Hopefully we're allowed it here. Minus 100. Plus 100. Okay. Which is square root of 676. And then I plugged it into the calculator again. That's 26. So sine of A is opposite 10 over hypotenuse 26, which is 5/13. Let me see if that's correct. 5/13, yes. Okay. Right triangle above. Cosine x is 3/5. Okay. If BC is 12, what's the length of AC? Okay, so cosine of x is 3/5. Okay, which sides does the cosine use? It's adjacent, which is CA, over hypotenuse, which is BA. Okay, BC is 12, and we're interested in AC, so maybe we have to use Pythagorean theorem. No, actually, now that I think about it, can we draw a similar triangle to make my life easier? So you can use the Pythagorean theorem and substitute all your variables until you solve for AC. But why don't I draw a similar triangle? This is x still, okay? Because I know that cosine of x is 3/5. What length is this then? This is the 3, 4, 5 triangle, okay? So what's the length of AC? Well, to get from this triangle to this bigger one, what's the scale factor? That's times 3. So to get this way, you have to divide by 3, but do I need that? What's the length of AC? No, I don't need that. Because AC is this bottom one. 3 times 3, that is 9. Okay, that's one way to think about this. Otherwise, you could have did, you done like AC squared plus BC squared is AB squared, and then you know this, and then you can rearrange terms over there to solve for AB or BA, and then you solve for AC. So that's obviously a little more work than just doing it like this. Okay. Sine of 5x minus 10 equals cosine 3x plus 16. What is the value of x? Well, we know these two need to be complementary. The arguments of the sine and the cosine need to be complementary. So 5x minus 10 plus 3x plus 16 equals 90. So 8x equals, this is 6, so 84. All right. So x is 84/8. Okay. If we divide by 4, that's what, 21/2. Okay. That's the answer. And that's it for this entire unit on, what was it, the advanced trig and quote-unquote advanced algebra and trig in this book. So hopefully this has been helpful for you if you've been following along and practicing. Of course, if you feel like you need more practice, there's lots of resources online. Just search up the topic and you can get a bunch more problems online. And a lot of the resources online have answers as well. So that's good for you to check your work. All right. As always, please like and subscribe if you found this helpful in any way.